Hello everyone, I am Kunjal, a Master of Science in Computer Science student studying at the University of California, Davis, working under the guidance of Professor Mohammad Saduki. I'm here to present my MS project titled ResInsight. It's an AI-driven developer ecosystem. So I'll tell you a story first, which will help you understand the core problem and why I chose this problem statement. So during my first quarter at UC Davis, I took ECS 265, a course which was focused on distributed database systems and the blockchain technology using ResilientDB. We were tasked with understanding the ResilientDB architecture, its consensus protocols, and building projects using the existing applications that the lab members had developed over years. Like many of my classmates, I came in with limited exposure to distributed systems. The learning curve was real. ResilientDB is a powerful, well-architected blockchain platform. Its sophistication is one of its greatest strengths. But that same sophistication meant there was a lot to understand, from Byzantine fault tolerance theory to the practical aspects of getting a development environment running and start using ResilientDB. Many of us found ourselves in a cycle, reading through the documentation, trying to set things up, hitting errors we didn't understand, and then relying on our groupmate setup who had managed to get their environments working. Some students spent most of the quarter developing on their teammates' setup rather than their own, not because they didn't want to figure it out, but because troubleshooting took time away from actually learning the concepts and building projects. Now, this wasn't anyone else's fault. ResilientDB as an active research platform evolves quickly, which is excellent for pushing blockchain innovation forward. But it also means documentation and setup procedures are constantly catching up. The platform's comprehensiveness is a feature, not a bug. However, for newcomers, this creates a genuine challenge. Now, you might be thinking, hey, Kunjal, you could have just used an AI agent like ChatGPT and asked it to explain ResilientDB and the setup procedures by just pasting the GitHub repo URL and scanning the README. You're right. But where the existing AI tools failed, we couldn't just ask ChatGPT or Claude for help. Because when you ask ChatGPT about ResilientDB, it gives you generic blockchain advice that may or may not apply to our specific implementation. I remember after our first class, all of us went to ChatGPT and we searched what ResilientDB is, how do these applications work, or what are these applications doing internally. And ChatGPT gave us very generic information about distributed database systems because, after all, it is trained on the public data that is available online, which was limited at that time. And it tries to guess and it tries its best to provide you an answer. But that answer might not be accurate and you cannot verify if it's actually correct. It hallucinates the repository structures that do not exist in ResilientDB, cannot access actual code from our repositories to verify its suggestions. It provides outdated setup instructions based on whatever documentation is available online. It doesn't know about ResilientDB specific applications which are deployed recently or which were deployed recently, like REST County. And it could not distinguish between theoretical PBFT and how ResilientDB actually implemented it. So here lies the fundamental gap. General purpose AI tools lack context about your specific code base and ecosystem. They are trained on public data, but have no connection to your actual repositories, your project's conventions, or your domain specific implementations. This gap becomes especially challenging for research platforms where the code evolves faster than public documentation can keep up. Internal applications and recent features aren't well represented in AI training data. Setup procedures vary based on specific use cases and environments. Understanding requires connecting theoretical concepts with their actual implementation in the code base. But now you might be thinking, can't I just describe what I need to an AI, provide it all the context, all the files, all the links, and have it build the solution? Here's why that doesn't solve the core problem. ChatGPT doesn't know about your specific code base. It can't tell you which file implements consensus in ResilientDB or where transaction processing is actually happening. Even if you copy paste code snippets to ChatGPT, it processes them in isolation. It cannot build a knowledge graph of the entire repository, explain you how one file is connected to the other, or for a particular functionality, how files are interlinked. The most important being the consistency problem. Every time you ask ChatGPT about your code, you need to provide context again and again. There's no persistent memory of your code base structure. ChatGPT has a memory actually, but that's limited. And once it's full, you need to clear it. Once you clear it, you will have to give the entire context of your project or your ecosystem again and repeat the process. When ChatGPT suggests something about ResilientDB's implementation, how do you actually know if it is accurate? Do you really know if the setup instruction that it is giving based on your system is correct and verifiable? After all, it's an LLM and it's just trying to guess and provide an answer based on the maximum probability. There's no way to trace its answer back to actual code or verify it. So what we needed wasn't just an AI tool that could answer our questions easily. We needed a tool that's connected to our actual ecosystem and can retrieve, analyze, and verify information from our specific repositories and applications. So I thought of building ResInsight, which bridges the gap by connecting AI agents to our ResilientDB ecosystem using an MCP. Now, instead of asking ChatGPT general questions like what is ResilientDB, what applications it has, how do they work, user can ask specific application-focused questions like how is transaction processing implemented in Orion, or what are the dependencies for the debatable application. Now, without MCP, that is a normal ChatGPT, what it would do is if the user asks what is in ResilientDB right now, the LLM would guess, hallucinate, or provide some outdated assumption-based answers. With MCP, that is ResInsight, LLM can actually query the system. So I'll give you a quick difference. Without MCP, ChatGPT is a knowledge model. But with ResInsight, an AI agent like ChatGPT or Claude, it acts as a system operator. Without MCP, answers are based on the training data. With MCP, answers are from the live system tools. Without MCP, there's static reasoning and static reasoning. With MCP, it's dynamic system introspection and verified data directly from ResilientDB. So an AI agent is just a planner or a reasoning loop, and it decides steps. It may call tools and tries to complete tasks end to end. But ResInsight is not the agent itself. It is a structured tool layer that agents like ChatGPT or Claude can use. Now, what makes ResInsight different? These are the five important points that make ResInsight different from any other AI agent. Repository-aware intelligence. Like I said, ResInsight does not guess. It searches, analyzes your actual code base, fetches the information and provides answers based on the current code and not the outdated documentation. I used something called as a hybrid search architecture, which is a combination of FAISS vector search and NetworkX knowledge graph. Now, what is FAISS? Why are we using this? Before hopping on to FAISS, I would like to explain you something called as semantic search. Now, what is semantic search and why are we using it here? So, a normal keyword-based search only finds the exact keywords. For example, if I ask what is Orion, it is one of the applications in ResilientDB, which has been developed using ResilientDB. So, using keyword matching, what would happen is the AI agent or the LLM would go match the specific keywords from the user's prompt, and if the keyword has been matched, it would give the answer. Now, if developers ask intent level questions like where is transaction ordering logic, there might be cases wherein your code base does not have these specific keywords or that specific language. In that case, your LLM might not return anything. but the logic for that particular question that the user has asked already exists. But just because the keyword did not match, the LLM did not return anything. So here semantic search helps because it maps meaning, so it can retrieve the relevant code even with different naming conventions. So yeah, when a user asks where is transaction ordering logic, rather than just matching keywords for transaction ordering logic, it would go understand where transaction related, finance related implementation has been done in that particular application. Now coming on to FAISS. What is FAISS? So FAISS gives you low latency retrieval at scale, which is critical for interactive MCP use. So we have large code base like a GitHub repository. Once the repository has been accessed, it is converted to code chunks. Those code chunks are converted to vectors for easy processing. And then you need fast nearest neighbor lookup. A brute force comparison against all the chunks becomes really slow as repositories grow. And such heavy architected repositories are really large. So you need something called as FAISS to give you low latency retrieval and optimized search across those code chunks and vectors. We all know how indexing is important. With indexing, you get repeatable, fast, and cost efficiency query handling. Without indexing, you would be querying through the entire vector search, and every query would rescan and re-embed the large code bases, causing slow and inconsistent responses. I am also creating a knowledge graph. So vector search is great for semantic similarity, but it is weak at explicit structure. So what I'm doing is I'm creating a knowledge graph which captures the relationships. For example, for a particular functionality, what are the files related to this functionality? If I want to place an order, what are the files related to placing an order on this website? It will capture all of these relationships. So this is how you answer architecture questions, not just find similar text. And with the help of diagrams or images, it is easier for the developer or the user to comprehend the information rather than just text. So I'll be providing a chart that helps the user understand, okay, this is how this functionality is linked to this one, this file is linked to this one. Now, with all four things together, semantic search, which is used to understand the intent, FAISS, which makes the intent retrieval fast, indexing, which is making the production usable, knowledge graph, which is explaining the structure and dependencies. Together, they turn the system from a random chat assistant into a repository grounded engineering tool. Let's take a scenario to explain how ResInsight would work. Um, a traditional experience would be when a user has been assigned to understand ResilientDB and build an application on top of ResilientDB, what they would be doing is they would understand what it is, how it works, how the database is working, what are the setup instructions, how are the exists. So ResilientDB currently has 14 plus applications deployed. How are these applications developed? How are they working? If there are any applications that are linked to each other, how have them been developed? So what a traditional approach would be to clone each repository, hoping a README exists and it is updated, then trying to understand the dependencies by reading some package.json or the requirements.txt file. For example, once you clone the repository, you can use Copilot and ask it the information like, hey, can you help me explain this code base or the file which is currently in the context window? And it would check, attempt setup following possibly outdated instructions, debug environment issues, eventually piece together understanding through experimentation. Now, tools like you might think like tools like Cursor or Copilot, they do provide integrated repo understanding, which is inside an ID, which I just explained you can do. How would that not make a difference? That is because my project differs in that it builds the underlying system and exposes it directly through an MCP for agent-based interaction, which makes it extensible, reproducible, and suitable for research and system-level environments. I'll deep dive in the further slides. So with the traditional experience, This exploration, cloning of each repository, understanding how each file is related to one another, what are the dependencies, that consumes significant amount of time, which should have been spent on actual project development. With ResInsight, the difference is you can understand the entire project or a n number of projects within a few minutes and start developing from the next hour. Because here you're not cloning each repository, understanding the file systems, using Copilot to explain you the information, and then once you are done cloning another repository and repeating the step. Here you just provide the context to ResInsight, ask specific questions. What is this application? How is this working? How are the queries being sent? How are the API calls being made? And within minutes, you have a pretty good understanding of a particular application. From zero understanding to basic comprehension in a few minutes with the confidence to start building and saving a lot of time. So here I've given two examples, which is related to the debatable application of how it is integrated and how it handles data uploads. Talking about the architecture, the major part of the project is the MCP server, which will be connected by the user to an AI agent like Claude or Copilot. And then you have the MCP, and MCP is connected to the backend server, which is providing or exposing the tools, resources. The high level architecture layers are the client layer, which is Claude, for example. Then you have your protocol layer, which is fast MCP. Then you have a security layer, which is a bearer token middleware, and which enforces access control. Then you have the server layer. Inside the server layer, you have the data acquisition layer, wherein there are GitHub APIs and raw file endpoints, which fetch the actual repo state and called as per the user needs. Then you have the intelligence layer, which includes the hybrid search, which I just explained, the embedding model, FAISS index, and graph analysis, creation of knowledge graphs using NetworkX. Domain layer, which includes the ResilientDB knowledge base, which has been separately created for project-specific guidance. Then the response layer, which provides structured tool-specific outputs with clear provenance. The core implementation has been done in the backend server. So a request lifecycle would look like a user would ask a question to an MCP client, which is, for example, Claude. The client, Claude, invokes one specific tool based on the user's prompt. If the user said list files in this particular directory, this is a very simple prompt, but it can be too specific based on your app need. So now let's consider the prompt to be list files in a directory. The client will call the MCP server. MCP server will check if I have a tool, if I have a tool that can give me such an information like files in a directory. If it exists, I would return it to the AI agent, and the AI agent, upon receiving the information, would format it, structure it in a way, and provide it in a structured format to the user. So the server fetches once the call has been made from the client to the MCP server, the MCP server fetches the repository data live from GitHub APIs upon calling that list files in a directory tool, not from model training memory. So the server would transform the data with deterministic logic. It would embed plus FAISS for semantic retrieval. Then if a graph is needed, it would use NetworkX and the knowledge graph creation tool for dependency graph extraction. And lastly, knowledge-based query for ResilientDB specific answer. And finally, upon collecting all of this, the MCP server tool will return structured output to the client. Security. So like I said, there's a security layer, which is based on the bearer token. And we have one of the most important tokens we're using here is the MCP token authentication, which will be provided by the lab to authorized users. So all client requests would require this token. For making GitHub API calls, we have the GitHub part authorization, and There are no environment-based secrets credentials that are mentioned in the code, and all inputs are sanitized and validated. Impact, like I said, if you are supposed to analyze multiple applications, you need not clone each one, ask the integrated AI agent with your ID, like Copilot, to explain you, and spend time exploring on your own or guessing. Such tasks, such mechanical tasks, which took days, now would take a few minutes or hours, depending on your need. And questions that required waiting for senior developers or lab members get answered immediately. So now the user can start working on it independently from day one. When setup actually works the first time, you understand why code is structured in a certain way and you actually find what you need. The confidence compounds over time and you get a hit and a motivation to start building. Information that was previously locked and you were dependent on your group mate setup or the lab member setup is now available to everyone. So new developers can explore, get their hands dirty, learn at their own pace, get accurate and precise information. In conclusion, I'd like to say that ResInsight is designed for a specific problem, which is helping developers understand and work with the ResilientDB ecosystem. It's not trying to replace developers or automate any coding tasks or solve every development challenge. What it does is eliminate the frustrating parts of onboarding, the hours spent searching for the right file, the days debugging environment setup, the uncertainty about whether you are understanding things correctly. By handling these mechanical tasks, REST Insight lets developers focus on what actually matters: understanding concepts, building features, and solving real problems. REST Insight is not AI chat over docs. It's a secure MCP toolchain that grounds answers in live repository data, structured analysis, and domain knowledge. Thank you. So now I'll explain how ResInsight works. Currently, I'm in the Claude desktop window. And I've already connected my MCP server to Claude. So I'll show you how I configured it for Claude. So for any AI agent, you just need to add the MCP server and the HTTP endpoint to its configuration file. And once that's done and your MCP server is successfully connected, you can start using ResInsight. So for Claude, you need to go to File, Settings, Developer, and there's this Edit Config button. Once you click on this Edit Config, it will open a Claude config.json file. In that JSON, there's an empty JSON body. In that body, you need to add the name of the MCP server, which is this, which will be the key. And in terms of value, you need to pass a few arguments, which would be MCP remote, the deployment URL, HTTP endpoint, and the bearer token, which you will be receiving from the lab and by requesting it from Professor Sadogi, and the authorized users will have access to this token. Once you specify all of that information and configure it, you can just close the file, come to Claude, make sure it is connected, and how to check if it's connected. Once when you click on this plus icon, you go to connectors and you get to see the MCP server which is running. So this is how you can configure it. The how to run the system or how to configure the MCP server. All of this information has been mentioned in the blog as well as the project's README file. So now I'll show you the working. I gave Claude a few prompts and asked it to explain. So my first prompt was, pretend that I'm a new developer and help me understand this repo in under 2 minutes, what the main entry point is and what the execution flow is. And if I want to start building or add a particular feature which is related to transactions, how I can do it, where I can do it, and help me explain with a diagram. So it called once this prompt was received, it called the MCP tools, which was get repo summary because we asked it to explain the repo. So it called the get repo summary MCP tool, the list GitHub repo files tool, the search ResilientDB knowledge base tool, MCP tool, get file summary. So these are all the MCP tools that it called. Once it called all the tools, gathered all the information, it started documenting it and presenting it to the user in a structured format. Because we asked it to create a diagram, it created a diagram which shows the entry point, how each file is related to each other, or for a particular functionality, what are the files that exist. So for this is the diagram that it created for Array, which consists of different functions like landing page, inventory page, smart contract, and a login. And it also explained what it is, what is the structure, how you can use what each file means. And if I want to add my transaction processing feature, how I can add it, how based on the how do ResilientDB APIs work, what is the request that is being sent, what is the response that we expect as a user, and this is how it explains us in a clear way. It also gave me a diagram which I did not ask about transaction processing flow. The next prompt that I gave it was how to trace inventory upload to the DB in step-by-step information, how a backend, where to add the backend resolver in ResilientDB GraphQL, can you fetch live ledger state from ResilientDB, and explain any anomalies, trace transaction provenance across nodes. Again, it called all the necessary MCP tools first to gather information, get file summary, search, ResilientDB knowledge base. So these are the MCP tools that I have written, and they currently exist in the server, backend server file. List GitHub repo files tools. If you click on it, you get to see what request is passed and what is the response that the MCP tool returned. Get file summary, request, response. It created a comprehensive visualization using the complete flow for the project along with the backend. In order to add the GraphQL resolver, it gave a nice flowchart which would explain me about each file, what they do, and what APIs are being used. And for DB writes, what API calls are being made, and how I can add a particular function. So this is the information that it collected from the MCP tools, and now it is presenting it to the user in a structured format. So this is how ResInsight works. And yeah, I would be happy to answer any of your questions. If you have any questions, please email me or you can email Professor Sadogi, and I would be happy to answer any of your questions, and looking forward to students, incoming students and developers using ResInsight and making the full use out of it. Thank you.